Hey, what's up, everybody? So we have some notes today. This is still section 1.3 in the book, but if you haven't noticed, I've broken up the sections into 2 or 3 parts, depending on how much I think I can give you guys at a time, because I don't want to overwhelm you with certain things, even though it does seem like we've been taking notes a lot lately. But anyway, this one is angle pair relationships. Okay. And the first one, let's see, I'll just lower it down to there. These are called adjacent angles. And the description is basically 2 angles that share a common vertex and a side. Okay. Now remember, if you guys hopefully remember, this dot down here is the vertex. Okay. So in order for it to be adjacent angles, they have to share that dot, and they also have to have the same side share. Now, it's also helpful if you know what the word adjacent means. When I hear the word adjacent, I think right next to. Okay. I'm not an English teacher. I won't say I know the best grammar, but adjacent means next to. Okay, I would think like my next door neighbor, he lives adjacent to me. 2 guys away from me, that's not my neighbor, and he's not next to me. He's not adjacent to me, okay? So next to, if I can spell, that says next to, okay? Angles that are pretty much right next to each other. So here we have an example. Angle 1 and 2 are adjacent to each other. And if you look at the definition, they both share this point and they both share this side, right? Because angle 2 goes from here to here, and then angle 1 goes from here to here. Okay? So they're both sharing that point and they share this side. But more importantly, I think they're right next to each other. Okay? And then underneath there, I put angles 1 and angle 3 are not adjacent. See, 1's way over here, and then 3's over here. Okay, they're not next to each other. They're not adjacent. Okay, so hopefully that makes sense. So let's move on. The next one we have is a linear pair. That's an angle relationship. Okay, and the definition or the description is 2 adjacent angles whose non-common sides are opposite rays. Okay, that's the definition you'll find in most books. I like to think if it's a linear pair, there's a reason why they call it a linear pair. It's a linear pair because they make a line, a straight line. Okay, so here we have these 2 angles, LMP, which is this angle, and then NMP, which is the other side, right? Together, if you look, they make a line. And technically, if we use that definition, these are opposite rays. The ray goes in this direction and in the opposite direction. Okay. Remember, for an opposite ray, that's a point and a ray, and then the opposite ray just goes in the opposite direction. Well, that's basically a line. Okay. And I like to call it a line more so because of the name. It's a linear pair. So it's 2 angles that come together to make a line. Okay. And then also, if you notice this from the assignment we did 2 days ago, when they come together to make a line, that angle is a half rotation. And here's something else about linear pairs. It's not part of the definition, but it's more of a characteristic. Linear pair angles are supplementary, meaning when you add the measure of angle LMP plus the measure of angle NMP, it will equal 180 degrees. Okay, that's a linear pair. That's a consequence or a characteristic of a linear pair. So these are important. These 2 right here. they're on, this one specifically is on the test we're going to take in like 2 days. You're going to be given a diagram and it's going to say identify the linear pair. Well, you need to look for the straight line. Okay. So let's look at the last example. The last example we have here of angle pairs is vertical angles. And this one, again, I really don't like the definition, but it's the definition that's in the book, so I use it. Two angles whose sides form two pairs of opposite rays. So let me just highlight the opposite rays. See, like, let me see, angle 1 and 3 are vertical angles, and angles 2 and 4 are vertical angles. Okay, so here's angle 2, and here's angle 4. So this angle, if I look at the definition, see here, this is an opposite ray, right? And that's true for the other side. This is an opposite ray. So that's why the definition is like that. Vertical angle, I just like, vertical means like this, right? So these two are vertical to each other. And then 1 and 3, angle 1 and angle 3 are also vertical angles. And then some people will say, yeah, but they're not vertical. You want to bet? You can just turn that page sideways. They're vertical, right? It's like this. So anyway, I like to say maybe look for an X, and the ones that are across from each other, those are the vertical angles. So anyway, angles 2 and 4 are vertical angles, angles 1 and 3 are vertical angles, and then a characteristic of vertical angles, they are congruent, meaning they're equal to each other. They have the same angle measure. So angle 1 is congruent to angle 3, angle 2 is congruent to angle 4. That's it for that. And again, that is going to be big on the test that we take in a couple days. These two. So let's go over some quick examples. So you can pause it if you need to copy this diagram. I'm going to answer these 3 questions based on this diagram. So the first question says, identify angles that form a linear pair. Now there's a bunch of different ones you can choose from here. But again, if you go back to this other page, you see linear pair looks like this. It forms a line. Let's just choose a line. Let's choose this one. Let me highlight it. Let's choose this line. That's a little crooked, but you guys get the idea. This angle and this angle make up that line. So we can say angle 1 and angle 2 form a linear pair, right? Or if you looked at the bottom ones, you could say angle 3 and angle 4. Okay. Or even if you looked at, let's say, you looked at this line here, you can say angles 2 and 3 form a linear pair because together they make this line. There's a bunch of different answers you can put for this one. I just chose that one because to me it seems like it's the easiest one. There's the line, there's angle 1 and angle 2, and they form that linear pair. So then this one says identify a pair of vertical angles. So remember, vertical, they're across from each other. So angle 2 and angle 4 are across from each other. These are vertical angles. Angle 2 and angle 4 are vertical angles. And instead of writing out angles, I'm just going to use the symbol. Okay. And then the last thing, it says if the measure of angle 1 is 115, so I'm going to put 115 degrees here, find the other ones. Okay. Well, we said over here in the notes that vertical angles are congruent. So if vertical angles are congruent and this one equals 115, this one also has to equal 115. because these are vertical angles. They're across from each other inside this big X. So I know angle 3 is 115 degrees. And then we just said up top, we said these two form a linear pair. And whenever it forms a linear pair, remember from the assignment we just did a day or two ago, these two have to equal 180 because it's half a rotation. So if they have to equal 180, let me turn this calculator on. 180 minus 115. I know this other side over here is 65 degrees. That's angle 2. So that's the measure of angle 2. And then again, these two are vertical, and vertical angles are congruent. So there we go. We got those. Hopefully that makes sense. We're going to do some of these today. And then finally, let's solve these last two. Since we were just talking about vertical angles, I know that angle and that angle are vertical angles. Let's solve this first. And since they're vertical angles, again, vertical angles are congruent. Set them equal to each other. Divide by 8, divide by 8. X equals 10. Right? And this is a linear pair. They're adjacent and then make a line. Okay? They form this line right here. They form that line. Okay? And more importantly, it makes that little half rotation. When it's a half rotation, it's 180 degrees. Or from over here, again, we know when it's a linear pair, it equals 180 when you add them. So that means 3x plus this one. And then again, we just did a whole page like that. Actually, 2 pages equals 180. Solve this. So subtract 48 to both sides. Bring down the 3x. 48 minus 48 is 0. 180 minus 48 is 132. Divided by 3, divided by 3. X equals 44. And that's it. If you need more time, pause it. I am going to stop the video right